Hello everyone, welcome to this next video on field theory. In this video we are going to see what is the characteristic of a field, right? So characteristic in general, what is it? If suppose we have some population of persons, right? Then one person is tall, another person is fat, third person has large IQ and so on. So these are what? These are the characteristics of different persons which identify them. So characteristic in general, we all know that is a feature or a quality belonging typically to a person, place, etc., which is used to identify them, right? Similarly, for algebraic structures, particularly for field, we can say that we associate a number with a field that is the characteristic of a field, and this characteristic is used to identify a particular field, right? So what do we need to find this characteristic of a field? We need the multiplicative identity of the field, which usually is 1, and we need the additive identity of the field. What is that? That is 0, right? So using these two, how can we determine what is the characteristic of the given field? So what you need to do to calculate that, you just take the multiplicative identity, that is you just take 1 and then you add up 1. How many times? The smallest number of times you have to add 1 to get 0. That is called the characteristics. That means you have ones, you add these, and whenever you get 0, that smallest number here, this gives the characteristic of the field, right? Let us see this using an example. Actually, this is absurd that how do you get 0 when you add up ones? Because in our mind, it is usually that we are in our mind, since our school, primary schools and whatsoever, we are counting in naturals and natural numbers. Therefore, in our mind, we have a thing like that ki whenever we add 1 to some other ones and then keep on doing that, we will never obtain 0. So what is this definition tells you? So here we need to think about this field structure abstractly. For example, if you take the field of rational numbers with the operations of addition and multiplication, in that case, when you add 1 plus 1, you'll get 2. When you add 1 plus 1 plus 1, you'll get 3. When you add 1 plus 1 plus 1 plus 1, that you'll get 4, and so on. That means how many times, whatever the number of times you add 1 to 1, you'll never get 0. So you cannot obtain 0 anytime, right? So this cannot be achieved for this case, right? So that means we say that there is no number in the field of rational numbers such that this thing is true, right? Therefore, we say that the characteristic of the field of rational numbers, that is equal to 0, right? So let us see in what case we can obtain this thing. Similarly, we have the case for the field of real numbers and the field of complex numbers. So when this thing is true, we just need to check, and for that, what is the characteristic? Let us see that. I've already told you the same is the case with the set of real numbers, field of real numbers, and with the field of complex numbers. The characteristic is 0 because whatever times you add 1 to 1 and so on, you'll never be able to achieve 0. The sum won't be equal to 0 at any time, right? So let us consider another example. Here I have considered a set Z2 together with these two operations, that is addition modulo 2 and multiplication modulo 2. Now this forms a field. We all know that. We have seen several examples. So now let us see, is there a characteristic of this field? And if it is so, what is it? This is basically a binary field. And this is very useful when we deal with computers because the computers work only on two numbers, 0 and 1. So basically this field is helpful, has applications in computer science, right? So let us create this tables. You all know how to do that. Firstly, we'll take the addition modulo 2 table. We'll write the set elements here as well as here. Then what do? You do 0 plus 0, that is 0. You divide that by 2. What you will get? 0 as a remainder. Then you add 0 and 1, that would be 1. When you divide 1 by 2, you will get the remainder as 1. Again 1 plus 1, that would be 2. When you divide 2 by 2, you will get the remainder as 0, right? Similarly this number. And here what you do? You multiply these two numbers, 0 and 0, that would be 0, divide by 2, the remainder is 0. Again you multiply 1 with 1. For this, you multiply 1 with 1, that is 1. When you divide 1 by 2, you will get the remainder as 1, right? So we know how to make these tables. So from here, can we find out a characteristic? So using this table, because we are interested in finding the characteristic, here we can add 1 and 1. We have just done that. 1 plus 1, that gives us 0, right? So that means we'll get 2 into 1 is 0. That means you say how many times did you add 1 to obtain 0? The answer is 2, right? So the characteristic of this field is 2. So in this case we obtain characteristic, right? So this is the essence of finding characteristics. Moreover, this is a result, and in fact this is very important result, that characteristic of any field ZP, where P is prime, its characteristic is that prime number, right? So this is a result. You should keep this in mind. To sum up, let's recall what we have done. In all fields, we know one exists, which is the multiplicative identity, and we also know that addition is a closed operation. That means that whenever you add any two numbers of the field, or three numbers of the field, or four numbers of the field, they again are in the field, right? Because of this closure property of addition. So they are obviously the elements of the field. That means 1, 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1, and so on. They all are the elements of the field. Now, there are two possibilities. One possibility is that these sums defined by adding all the ones, whether the sum of few of these that is equal to 0, or none of the sum is equal to 0. These two properties are possibilities are there, right? So in this case, when sum of the sums here is 0, so in that case we get the repeated elements, right? For example, in this case we obtained 0 and 1 as the repeated elements. So the only elements present in the group in the field are 0 and 1. If you take any other integers also, in that case also you will get the number of elements of this field as finite, right? So in whereas in this case, because none of the sum is 0, so that means the characteristic of the field is 0. There are infinite number of elements, because for every summation of ones you get a different number. That means the number and you can do this thing infinitely many times. That means the number of elements here would be infinite, and we can say that the elements do not repeat, right? So here in this case, characteristic of a field, what is that? That is the smallest positive number of ones whose sum is 0. So remember, the smallest is important over here, because if you keep on adding 1 and 1 and 1 and 1, you will get again 0 after certain period, and if you keep doing that, you will again get 0. So the smallest here is important, because that is defined as the characteristic of a field. So in this case, the characteristic of characteristic of a field, what is that? We denote characteristic by this ch, small ch f, right? So the characteristic of the field is the smallest positive number of ones whose sum is 0. And in this case, because no such sum exists, that means the characteristic of the field is 0, right? That's it for this video. I hope that's enough, right?